Okay, taking a look at this DT466 engine, it's a diesel turbocharged 466 cubic inch engine. I'm going to diagnose this engine for a running related problem. This engine in the lab here is not running because it has low compression or a compression related problem. So what I need to do is find out where we're losing the compression pressure to be able to have the pressure in the cylinder to create complete combustion. Now, one of the things that I've gone ahead and done is I've hooked up a remote power supply to our cranking motor. We have no fuel at this engine right now. It only has residual fuel that is sitting in the pump. So what I've done is I've hooked up also a remote starter to it. And then I'm going to go ahead and I'm going to crank the engine, and I've already gone ahead and done this prior to starting the video, and you can see that there is compression pressure leaking right from the top of the engine. So one of the first things you need to do is make sure that you do know how to start the engine through the throttle control and know how to shut the engine off through the fuel shutdown so that the engine will not run during this process or deliver any fuel. So I'm going to go ahead now and crank the engine and take a look and see where I'm having the related problems. I can hear the compression pressure coming out of the engine, but I need to find out where it's leaking from and check all the cylinders for their functional capacity. Okay, I just hooked up this engine and I went to start it. We had some running related oil leaking problems, so we took care of that to begin with so I can do the testing in the lab. One thing that I noticed when I did run this engine is right at this injector here that it's actually spraying fuel out of the injector cup, which tells me that I'm losing compression pressure because the fuel is not sealing into the cylinder. So it may be a compression washer at the bottom, or it might actually be something to do with the injector cup itself. Okay, so we're going to go ahead now and we're going to run the engine and we're going to have a close look at where we're leaking compression pressure, or in this particular case, it looks like we're seeing a bit of fuel coming out of here. So I'm just going to run this. It may be hard to hear me talking as I look at it, but I'm going to look at all these injectors as we run it. You can see right here that this one's actually putting out quite a bit of fuel, and so is this one. And when I rev it up a bit, you can literally see the fuel coming out of it. So now that I know where there are some potential leaks here, number 1 and number 3 cylinder, I can take note of that, and then when I'm going through my compression testing, I can look at why I'm losing that pressure and where I'm losing that pressure. And when we continue through the process and get to the cylinder leak testing, we can actually determine where we're losing the pressure in the cylinder, whether it's out the exhaust valves, whether it's by the rings in the bottom end of the engine, or by the intake coming out of the intake valves, or simply losing compression pressure at the seal on the injector and the injector cup. Okay, as I was saying here, the potential leak could be coming from the injector sleeve or the injector cup. So the injector sits down inside here and then is sealed at the bottom with a compression washer. So that sits down at the very bottom. So that could potentially be the problem here. Now, I could be losing pressure around the top where it seals into the boss of the head, or I could be leaking at the bottom where the compression washer sits on the inside. Okay, so now that we've ran the engine and we've seen where the fuel is leaking from number 1 and number 3 injector, now I can use that as part of my diagnosis when I'm trying to figure out where I'm losing the compression pressure. When I use the cylinder leak tester, I can actually help diagnose where I'm losing the pressure, either through the intake valve and I hear it in the intake, or out the exhaust valve and I hear it out the exhaust, or maybe I hear it just leaking down into the bottom end, which indicates excessive blow-by on the rings. So I would hear that at either the oil pickup tube, or I could hear it at the crankcase breather vent, and on this particular engine, it comes off the top of the valve cover. Because if you remember, the oil return galleries are common from the top to the bottom of the engine, and that's why we would hear blow-by gas at the valve cover as well as at the crankcase. Okay, going to carry on now with the process of getting the engine stripped down so I can take a look at where I'm losing my potential power in the engine. I'm going to have to go ahead and take the valve cover off because on this particular engine, I am going to do what's called a top set. And the top set includes on a lot of engines setting the valves and the injectors, but on this engine we only have valves that we have to set under the valve cover because we have a PLN system, pump, lines, and nozzles, okay? And we call that a mechanical injection system. So I'm just going through and taking off the valve cover and all the fasteners for it so I can physically take a look at what's going on under the valve cover, look for loose valves, or maybe even look for tight valves depending on the conditions that are happening in the engine when I do the testing, or in the trade, what the customer actually complains to your foreman about, and then a work order supports the potential problem or the service work that maybe need to be done on the engine. So one of the things that's important too is when we remove the injector lines, we are supposed to use a crowfoot wrench. So the crowfoot wrench, it allows us to go into tight spots and remove and loosen off the injector lines. Now, a lot of times what ends up happening is students and technicians, they come in here with a wrench and they crack these loose and they start to round off the fittings. So it's important to use the right tool for the right job, and it makes it easier to do the repair and the service work. So I'm just going to continue on to take these lines off and get to that point where we can start doing some testing on the engine. Okay, so continuing on, I've removed some of the components that I need to access on the engine itself. So I need to get to the injectors, and in order to do that I need to remove the injector lines. So I've gone ahead and removed all the nuts from the injectors and from the top of the delivery valves on the injection pump. So the last one, just it's finger tight, take it off, and you can take the whole rail off and set it aside until it's ready to go back together. So the next thing I'm going to do is come in here and I'm just going to lift this valve cover off because I've loosened it, and take the gasket with it, and we'll set this aside until we do the reassembly. Okay, I've gone ahead and I've removed a bunch of the injector hold downs. One in particular here on number 3, and number 3 was one that was leaking fuel. One thing that I noticed right away was that the hold down is going this way when it should be going that way. So that's going to provide enough pressure to hold the injector down into its position so that it doesn't leak against the compression seal. So that might have been part of the problem from the last person that worked on it. So going back to this injector cup, what I've done is I'm just showing you what happens is the compression seal usually stays down in the bottom. So what we're going to use is a tapered heel bar, and we're just going to put this down in the cylinder and pick up the injector O-ring, okay, or pardon me, the compression washer. That gets it out of the engine. Some technicians say crank the engine over and let the compression pressure blow it out. Never use the compression pressure of an engine to do the work for you. We have the tools and the ability, use the right tool for the right job. So continuing, so now I'm going to go ahead and I'm going to remove the last 2 injector hold downs, number 1 and number 2. And then what I'm going to do is I'm going to pull out every single injector together at the same time. So I'm just going to lift up on them, and I want to try and pull them all out at the same time, and they're all connected. Okay, so just like I was talking about earlier on how we use this tool to get those washers out, I've had that problem on a couple, and it's really important when you do pull the injectors out that you count to make sure that you have all of the compression washers. So I'm missing a few here, so I'm just going to go down into number 1. There's the first one. And the second one that I'm missing. And the third one that I'm missing. So, number 1 and number 3 that were leaking fuel or compression pressure, I have the washers, so that eliminates my thought that the washer is collapsed or missing. Okay, so prior to doing any work from this point on, we've removed the injectors and we want to protect the delivery valves on the top of the pump. So we're going to put on caps to make sure no dirt and debris falls into the top of these delivery valves. The delivery valves are going to be what allows the fuel to leave the pump and go directly to the injectors. So now we're protected, we can carry on with the compression testing process. Okay, so carrying on, what I'm doing is I'm taking the dummy injector now, and it has a fibrine washer on here to promote the sealing, and it's a little bit thicker and it's a little more flexible to follow the contour of the injector cup, one, to help diagnose whether we're losing the pressure there or not because of the seal. So this seal helps promote that seal on this dummy injector during the compression test process. So we just put it in the cylinder, we use the OEM hold down going the right direction, and then we install the cap screw to hold the dummy injector into place. Now, typically most males can put about 30 foot-pounds of torque onto a fastener with a quick snap of the wrist. These should be torqued to OEM spec, but after you work with this stuff for quite some time, you get to know what is around 10 to 15 pounds of foot-pounds of pressure to hold this down. You just want to make sure it's snug, not over-tightened, because we don't want to crush down that injector sleeve. So we're ready to do the compression test for number one. We are going to do this as what's called a dry test, and we typically will crank the engine until we hear the engine load up about 4 times. When we hear it load 4 times, that's the compression pressure that's coming up against the movement of the engine that's actually creating that loading every time we hear that compression pressure build in the cylinder. And of course, it directly transposes onto the gauge so we can see the value based on the test. So I'm going to go ahead and just connect our engine compression tester. Okay, so I'm going to make the connection now with the quick coupler onto the top of the compression tester dummy gauge or dummy injector, and now I've got the gauge connected to it. This has a rubber backing on it to protect the gauge, okay, and it's also so in the event that if the back of the gauge blows off that it doesn't come apart in your hand. I would highly recommend that you do not hold compression testing gauges in your hand like this. Number one, if we look at the pressure that's available on this, it can go up to 5,000 kPa or up to just over 800 psi. I don't really want to have 800 psi in my hands. Now this engine is not going to produce 800 psi of compression pressure, but these gauges were purchased for testing these engines based on the pressure that this engine would have. And we're running in a safe range. So it's always important to make sure that you check the pressure rating for the compression pressure of the engine so that you use the corresponding gauge so that you're not putting the gauge at risk and most importantly, your own safety. So I'm going to set this thing down here and I'm not going to hang on to it. I'm going to press the release valve, make sure there's no pressure in it, and I'm going to crank the engine, and let's listen for the audible tone of the engine grunting through the compression stroke 4 times, and we'll look at what the gauge has for pressure. So now that I have the compression gauge hooked up, what I want to do is I want to take a look at and record on some sort of a chart the values that we get. First of all, we need to know how much it builds on the very first stroke. So when we build on the very first stroke, that tells us what the capacity is inside the cylinder to actually be able to build pressure to promote heat and the combustion process. So we record the first stroke and then we're going to do a build-up and go 4 to maybe 6 compression strokes to make sure that we don't keep building pressure. If it continually builds pressure, it just means it's slow to build, and then we have to look for the problem related to why it's slow to build. So first stroke. Keep knocking off my power supply. First stroke. And it jumps to 180 pounds of pressure. And then we're going to continue on for 4 to 6 more compression strokes. And about 350 is where it tops out. So first stroke and top or buildup is what we're looking for pressure. So I'm carrying on now, and I've removed the dummy injector from number 1 cylinder. I'm bringing it over to number 2 cylinder, and then I am going to connect my compression test gauge, and I'm going to watch for the buildup and for first stroke. First stroke, 225. Buildup, 425. That's number 2 cylinder. So then we're going to go ahead and remove this to go to number 3 cylinder. And I'm just going to kind of do this on the fly so you can see how quickly this process can happen. Oh, I'll just go over to number 3. Now remember, number 1 and number 3 were ones that we had concerns about when we first started and ran this engine for our initial diagnosis. There's number 3. So we connect our gauge again for number 3. Keep our hands free. Remove the pressure from the gauge. Build up first stroke, number 3 cylinder. 225. Build up, number 3. 410. Remove the pressure, remove the gauge, remove the dummy injector, and roll on to the next cylinder. So typically in the trade, you'd want to do this as quickly and as accurately as possible, and that's why it's important to have a chart of some sort to be able to record the information so that when you need to recall information, you can go back and you have documentation on your findings. And it's a really important thing, especially when we talk about warranty aspect and failed components in the engine. So now we're going number 4 cylinder, first stroke. First stroke is 250. Build up, 450. Disconnect the gauge. Go through the process again. Remove the dummy injector and the cap screw and the hold down, and we'll take it and drop it into number 5 cylinder. So number 5 now, we are going to do our first stroke and then our build up for more information on our diagnosis. So continuing on with the process, removing the pressure from the gauge. First stroke, number 5 cylinder. 225. Build up, number 5. 375 for build up on number 5. Number 6 cylinder, moving right along. Number 5 so far seems to be the one that has the lowest build up pressure of 375. Now, when we get into higher pressures like the one we had on number 4 cylinder where we got up to 450 psi, that's usually an indication that there may be some incomplete combustion and carbon packing on the top of the combustion chamber, which is the piston in this case, which causes a decrease of clearance volume, which causes an increase of pressure. So that may be where we're getting our increase of pressure, is from carbon deposits that take up clearance in the engine. So number 6 cylinder, number 6, first stroke, 300 psi. I'm going to say there's nothing wrong with the rings in that cylinder. Build up, number 6 cylinder, 425. I don't really have too many concerns about that, especially when it builds that quickly on the very first cylinder. So now that we've gone ahead and done all the diagnosis for the compression test, and this is done on a dry aspect. We don't ever do wet testing on a diesel simply because we have a very low clearance volume, and if we add something into that low clearance volume, then it's going to take up space and we could actually cause a hydraulic lock or tensile failure on connecting rods and other related reciprocating parts. Okay, so we've done our first dry test. We follow that up with a second test to confirm our diagnosis, because what we want to look at is we want to see that we have fairly consistent values between the two tests. If we're getting really skewed results, it may be tool related or a mechanical related problem in the engine where maybe a valve is not sealing on one stroke when you do the test, and then when you do the test again, it does seal. So it's going to give us different values. So it's really important to do a second test to confirm your diagnosis.